What does it mean to scale? Why is it sometimes necessary to use scale models or drawings? List some math terms associated with scale models or drawings. A scale model or drawing is used to represent an object that is too large or too small to be drawn or built at actual size. The scale gives the ratio of the measurements in the model or drawing to the measurements of the actual object. Remember, guys, a ratio is a fraction that is used to compare the size of two numbers to each other. Let's take a look at an example. One of the most common types of scale drawings is a map. Maps are very useful when planning a trip, whether it is across town or across the country. Norbert and Zot are planning to drive from NASA Kennedy Space Center to Washington, D.C. Norbert wants to estimate the distance he and Zot will travel. The scale on Norbert's map reads 1 centimeter equals 100 kilometers. How can he estimate the distance in kilometers from Kennedy Space Center to Washington, D.C. using the given scale? The scale can be written as the fraction 1 centimeter over 100 kilometers. The first number, 1 centimeter, represents the map distance, and the second number, 100 kilometers, represents the actual distance. First, using a metric ruler and the given map, measure the linear distance from Kennedy Space Center to Washington, D.C. On Norbert's map, this distance is approximately 13.5 centimeters. Now we have all the information we need to set up our proportion. Remember, guys, a proportion is a pair of equal ratios. The first ratio is the map scale, and the second ratio is the distance from Kennedy Space Center to Washington, D.C. Let's set these two ratios equal to each other. N represents the distance that we are trying to calculate. This proportion can be read as 1 centimeter is to 100 kilometers, as 13.5 centimeters is to n kilometers. In a proportion, the cross products of the two ratios are equal. In other words, the product of the top value from the first ratio and the bottom value from the second ratio is equal to the product of the top value of the second ratio and the bottom value from the first ratio. We can write the cross product as 1 centimeter times n kilometers equals 100 kilometers times 13.5 centimeters. Using multiplication, Norbert calculated the actual distance between Kennedy Space Center and Washington, D.C. to be about 1,350 kilometers. Students, here is an important point for you to remember. Proportions often include different units of measurements. Units must be the same across the top and bottom or down the left and right sides. If the units only match diagonally, then the ratios do not form a proportion. So guys, are you still having trouble trying to understand scaling? Okay, well, let's look at another example, this time using a scale model. Right behind me is a replica of the space shuttle. And this right here, this is a scale model of the space shuttle. The actual space shuttle has a length of 37.2 meters, a height of 17.3 meters, and a width or wingspan of 23.8 meters. Now this shuttle model is a 1/100th scale of the actual space shuttle. Now that is 1 meter equals 100 meters. So using that scale, let's set up a proportion to calculate the length of this space shuttle model. The first ratio is the model scale, and the second ratio is the length of the model to the actual shuttle length. N represents the length of the shuttle model. We set these two ratios equal to each other. Now remember, in a proportion, the cross products of the two ratios are equal. We write the cross product as 1 meter times 37.2 meters equals 100 meters times n meters. Dividing 37.2 by 100 gives us the length of the shuttle model, which is 0.372 meters, or approximately 14.5 inches. Well, that wasn't too bad, was it? Do you think you can handle the other two dimensions? So now it's your turn to calculate the height and the width or wingspan of the shuttle model using the given scale. Remember, the height of the actual shuttle is 17.3 meters. The width or wingspan is 23.8 meters. And the scale is 1 meter equals 100 meters. It's now time to pause the program to calculate the height and width of the shuttle model. So guys, how did you do? Let's check your answers with mine. Earlier, we calculated the length of the shuttle model to be 0.372 meters. I calculated the height of the model to be 0.173 meters, or approximately 7 inches, and the width, or wingspan, to be 0.238 meters, or approximately 9.5 inches. Did you get the same answers? If you did, great job. And if you didn't, don't be discouraged. Just go back and check over your work carefully. Make sure you set up your proportions and multiplied correctly.